Hello, good evening. My name is Art, and today I'm going to show you a proposed experiment that will allow faster than speed of light communications. And I'm going to break down how it works and let you decide for yourself. Now, before I get started, a couple things in background that you probably should brush up on if you haven't would be the quantum wave theory, the wave function in quantum mechanics, a little bit about the double slit experiment and the results of when a wave breaks down, the pattern it makes versus when it doesn't break down, a particle going through the slits. These are things you can look up on the internet. And then lastly, the work that was done in the recent 2022 Nobel Prize by Alien Aspect, Anton Zeilinger, and John Clauser. They had some important breakthroughs that make this theory and experiment possible. Now, one other thing is the experiment that I'm going to describe is not practical, but it is possible. There's two different things. Possible in a world given infinite time, etc. It's not practical, because we're going to discuss on a cosmic scale how to design an experiment where you can talk instantaneously over light years apart. Something that was thought not possible and violates Einstein's theories. But things are meant to change. So here we go. One last thing is, I know it's not practical, so just look at the concept and assume some of my experimental, what you want to call it, license to push the experimental boundaries a little bit for showing a concept, and then later on I can come back and do another video and show how this experiment could be done in the practicalities of today's world on Earth. But I think for effect, the cosmic example is better. So here we go. So we're going to start with, I have these beautiful slides, and I want to get this concept out, and I didn't really feel like doing hours and hours of graphics. So imagine, well, not imagine, we have a particle generator which shoots a particle to a splitter, and this is all done in physics today using a prism or some other piece of mineral optical device that splits the particle into two. So this could be an electron, a proton. The point is, it splits it into two, and now the first particle is entangled and has two manifestations of itself. One goes to my left and one goes to my right, away from Earth into outer space. So we set that up, and this is going to be a stream of particles, not just one, just continual stream at whatever rate this particle generator can generate, millions per second or billions. I'm not too familiar with the rates or speeds of particle generation, but a lot. So there they go into outer space. Then I'm going to invent two planets that happen to be in a stationary position around Earth, which probably isn't possible at 1 light year away. But one is to the left, to my left, and one is to my right. And they're going to be planets Zolak and Zyborg. And they're incredibly convenient because Zolak is 1 light year away, and Zyborg is 1 light year less 100 yards. And that'll become apparent in a minute why it has to be less than 100 yards for this experiment to work. They can't be exactly the same distance, but inevitably they're very far, and of course there's 2 light years between the two planets. All right, and so the particles are headed towards Zyborg and Zolak in a nice straight line through space. Nice clear night, nice clear day, nothing interfering with them. And now in order to complete my experiment, I'm going to have to send 2 of my friends out to Zyborg and Zolak. So I have Bob and Jenny here. And Bob and Jenny, I'm going to outfit them with a nice synchronized clock that they synchronize together on Earth before they venture on their journey. And they head towards Zyborg and Zolak with their clocks. Oh, one thing about these clocks is they have time slots that they register every millisecond. And so they're in sequence. So 1, 2, 3, 4, 5, on up to however high they can count over the years. Every millisecond, there's a time slot, and an alarm goes off. It's each millisecond, and my friends Bob and Jenny will be taking action on those time slots. So first, let's go to Jenny. So there, Jenny, I sent her out to Zolak. Got to make sure. Sometimes I forget where I sent Jenny and Bob, and somehow she got there. I don't know, by rocket ship. It took a long time, maybe 1,000 years, but she's still alive, fortunately, and she has instructions. So what I asked her to do was to set up a magnetic polarization detection device on Zolak, and every millisecond I want her to decide if she engages the detection device or disengages it, meaning in one she has two options. She can measure the polarity of the particle, or she can just ignore the particle and let it slide by unmolested. Now, why would I want to do this? Well, it just so happens that in the world of quantum mechanics, especially when you have an entangled particle, so the partner entangled particle is heading toward the other planet, which would be Zyborg. If you act on it even 2 light years away, the other particle will have its wave function collapse, just like you would observe it in a traditional double slit experiment. So I'm observing the partner particle, and remember, I'm 100 yards short of 1 light year, so slightly before that particle shows up on Zyborg. Anything Jenny does to it will either collapse its wave function or let the wave function persist. So Jenny is sitting there, and every millisecond she does one of those two things. Now, we'll get to some more deterministic communication in a second, but she has that capability. Now, we go over to planet Zyborg, and poor Bob, he's out there with his clock, but I forgot to mention, I gave him a little double slit setup and millions of, or maybe perhaps billions of pieces of photosensitive film. So he can change out his double slit experiment every millisecond. So what Bob is going to do is he's going to sit out there on Zyborg, and every millisecond he's going to insert a new piece of film behind his 2 slits and intercept the entangled particles that are hitting the planet. And he's just going to observe the results. Now, from quantum and the double slit experiment, if the particle wave function collapses, the stream of particles, remember, it's not just one particle hitting there. For over the period of a millisecond, many particles will come through there during this time slot. And so he'll get enough particles to generate that pattern on that film. And so let's go back to Jenny. Let's suppose Jenny wants to communicate to Bob. What she will do is decide if she wants to send him a 1 or a 0. And a 1 corresponds to a collapsed wave function, and a 0 corresponds to an unmolested stream of particles. And so when Jenny holds up her detection device 100 yards short of 1 light year, that detection device, just by the fact that it's observing the entangled particle, will cause the wave function on that particle to collapse and all particles in that stream for the millisecond. Which in turn, when Bob sets up his detection device in the same millisecond, since their clocks are synchronized, will show a particle pattern, not a wave pattern, which is, again, you have to be familiar with the double slit experiment, but it looks different on the film. And when Jenny lets the particles pass without interfering with them, Bob will see a wave pattern. So every millisecond, Bob sees a wave pattern or a particle pattern on his film. So correspond to 1 and 0. And Jenny knows this. Jenny knows that Bob is over there. So Jenny decides she wants to tell Bob that she had a baby somewhere en route over the 1,000 years. So they both happen to know Morse code, ones and zeros, how you represent letters and symbols that way. So Jenny starts transmitting a sequence of ones and zeros every millisecond, and she changes it out corresponding to I have a baby in Morse code. And remember, this is getting to Bob instantaneously. It's not taking 2 light years. The particles that Bob is seeing are the partner particles that left the Earth at the same time as the partner particle that Jenny is manipulating. So the moment, instantaneous in time, that she detects that particle or doesn't detect it, Bob will be generating a wave pattern within a millisecond. And again, remember, they're 2 light years apart. So this shows that Jenny can send digital data to Bob faster than the speed of light. And that's it. Hope you enjoyed it, and let me know if you have any questions.